In recent months at ENA, we have been using Graylog, a log aggregation system. We use it to keep track of our interactive and programmatic submission systems. In this talk, I want to share what we have learnt so far and encourage you to try it with your own projects. So why did we start using Graylog? Our submission systems have been around for a long time, and we get errors. More specifically, our submitters get errors and report them to us through our help desk. Two types of submitters tend to go to the trouble of reporting: the most helpful submitters and the most frustrated submitters. There is also a group of submitters who experience errors but don't report them. We don't know how many of these there are, but these are the ones who are more likely to give up and submit through NCBI instead. Help Desk creates JIRAs for each error reported, and we work through them. In recent years, we have moved away from prioritising based on who shapes the loudest and now attempt to prioritise by potential impact. However, we are still reactive and tend to deal with a single error in isolation. When we receive an error, the detective work starts. An error report can be detailed, but it also can be as simple as, "I got an error while submitting." I spend time finding out submitter details. I then delve into logs on each server, looking for stack traces and other logging messages. When I have pieced this together and know what has happened, it usually does not take too long to get a fix deployed. We inform the submitter, and I move on to the next JIRA in the queue. Sometimes the submitter will come back and let us know that the problem has been resolved. Sometimes they don't. There are limitations with this approach. It relies on submitters reporting errors, it focuses on individual errors, and it is hard to verify that an error has been fixed once and for all. The most important point is that submitters experience errors. It is very easy to get into thinking that because we are fixing errors promptly and submitters are grateful, that we're doing a good job. I don't believe we are. Our submission system should be like air conditioning. You probably have not thought about the air conditioning in this room today, as it's working fine. It's boring. It's faded into the background. You have forgotten that a complicated system is there. Our submission system should be like that. They should work so smoothly that submitters think they are trivial. This is why we started looking at Graylog. We wanted to move away from reacting to individual error reports. Instead, we wanted to move towards detecting trends, resolving classes of errors, and preventing errors before submitters notice. Graylog provides a central destination to receive and store all logging messages from our applications. It then provides search, alerting, and analysis. With search, when a submitter reports an error, we don't need to go digging around in server logs anymore. We search Graylog. When we have found the error, we can see all occurrences. We can also see all logging information around the errors, giving us the context we need to understand them. Setting up monitors to track the error and get real-time counts and graphs of when the error is occurring means that when we deploy a fix, we can see the graph drop to 0. We're still reactive to error reports, but we are much more effective in resolving them. We can also define a baseline indicator and display them on a dashboard. If we normally get 10 submissions per hour and it drops to 0, we know something is likely to be wrong. If failed logins rise from 10 per hour to 1,000 per hour, likewise, we know something is amiss. We can set up alerts to flag this unusual activity to Slack or email. We can deal with it before submitters start contacting the help desk. We become proactive. For me, where Graylog comes into its own though, is with analysis. We can model the journey of submitters through the system. By creating and logging messages that act as checkpoints, we can see where submitters are getting stuck and this can be very enlightening. We can spot trends and use that to target our efforts on error prevention. For example, one option in our submission process is for the submitter to download template spreadsheets for entering sample data. They then return and upload the completed spreadsheet. With logging in place, we found that over half the attempts to upload spreadsheets were failing. Submitters saw a message telling them the spreadsheet was not in the right format. They were not reporting it as an error. However, it was certainly a source of problems, as we could see from the logs that in many cases it prevented them continuing their submission. When we looked at the screen in question, we saw there was simply a button named Upload Spreadsheet. There was no indication of what type of spreadsheet we were expecting. In Graylog, we were able to group failures into 3 categories: unexpected spreadsheet format, submitters were uploading Excel instead of CSV; unexpected type of file, submitters were uploading non-spreadsheet files. This issue first came to our attention when a submitter tried to upload a 150 megabyte FASTA file. The server ran out of memory trying to parse it. And unexpected content. The spreadsheets were the submitter's own spreadsheets and not based on our templates. This feature was causing a very high failure rate, but this fix was simple. Restrict the file extensions that can be uploaded and provide clear explanation text of what the upload spreadsheet function was for. When we applied this change, we are able to use Graylog to monitor the failure rate. We could prove that this change eliminated file-related failures. Content failures also were reduced to a fraction of what they were before, avoiding a lot of submitter confusion. These are some reasons we like Graylog. In this talk, I wanted to concentrate more on why Graylog was useful to us, rather than how it works. There is much better documentation and video online than I can create, but I'll give a very brief overview. Graylog is a standalone server that uses Elasticsearch and MongoDB. Log messages are collected in a JSON format called GELF and stored in MongoDB. Elasticsearch provides the search engine. Our instance is installed on a standard Technical Services Provided VM. It took me a morning to set up manually. If you can use Docker or Amazon Web Services, it appears much more straightforward, as you can just download pre-configured images. Graylog itself then provides a web interface that allows setting up of inputs, streams, alerts and dashboards. There are different options for getting data into Graylog. We are just using a single input that takes GELF messages on a UDP port. We use a library for Graylog that provides an appender to convert logging messages into GELF formatted messages and delivers them to a specific host and port. We then use Slack for our alerts. There is a library of official and third-party plugins, from big screen visualizations to automatic creation of Jiras, but we are using Graylog out of the box at the moment. It is very early days for us with Graylog. We are still learning, still exploring what is possible. We realise we are currently using a small fraction of its potential. For example, it can cope with 100,000 messages per second, and we're using 100 a second at most. We have not even started at looking at plugins, so we've only just scratched the surface of what it can do. However, it already shows real promise, as it enables a different way of working that could potentially make a big difference to submitters' experience of our services. We hope they would first notice a more responsive and efficient service when they do encounter errors, and in time find that they're not experiencing errors at all. I encourage anyone who would like to try Graylog in their team to do so and share your experience. We have limited time to spend on Graylog in our group, so help would be invaluable. If enough people are using it and finding it useful, it may be something we can ask to be managed centrally. Thank you.